Okay, today what we're going to do is we're going to go over question RS46 on page 219. Now rather than have everyone cut it out on their own, I'm going to do it so that way you can see how this thing works without actually having to cut it. So part A asks us to label the base and the height. Now the height is the distance from the highest point to the lowest point that creates a perpendicular. This little box right here shows that it's perpendicular. So what I'm going to do is I'm going to label this as the height. Then it says to label the base. The base is any length along the bottom side of the figure. So if I'm going to call this the height, I better call this the base. Part B asks us, use a ruler and measure the base and the height in centimeters and label them. So I'm going to measure my base and my height in centimeters. My base is 7 centimeters. I'm not going to bother with decimals because it's going to make our calculations a little more difficult. And our height is approximately 3 centimeters. Find the area of the parallelogram. This we did in our last lesson. The area of the parallelogram is the base times the height. So for part C, we're going to need to find the area. So remember that the area is equal to the base times the height. So in this case, the area is going to be equal to the base, 7 centimeters, times the height, 3 centimeters. So my area is going to be 21 square centimeters. Part D says to cut the diagram along the diagonal. So I'm going to take my scissors and I'm going to cut this parallelogram along the diagonal. Now what I have are, very good, 2 triangles. That's right. So for part D, I can say that I made 2 triangles. Now, we learned in science about the conservation of matter. Aside from some negligible little slivers of paper fibers, none of the paper disappeared. All of the area is still the same. Look at the part E says, look at the base and the height on both triangles. What is the area of each triangle? Well, I even cut out one. As you can see, this triangle right here, the height is still 3 centimeters. The base is still 7 centimeters. I didn't change the height or the base. And you can see that actually both triangles are exactly identical. Or they should be. The area of a triangle, if you'll remember, so for part E, the area of the triangle is equal to 1/2 of the base times the height. Or you could call it base times height divided by 2, whichever you want. So in this case, the area of each triangle is, the area will be 3 times 7 divided by 2, or about 10.5. Part F, how does the area of each of the triangles compare to the area of the parallelogram? Now this is interesting because not only if I take the 2 triangles and put them together, I'm back to the old parallelogram. But if I double the area of the triangles, I get the area of the parallelogram. So, the area of the triangle is 1/2 of the base times the height. The area of the parallelogram is base times the height because a parallelogram is really 2 identical triangles.